Hello students, how are you all? I hope you all are doing well. So today in this chapter, we will learn about measurement of length and motion, okay? So students, in this chapter, we will learn about how lengths are measured and how motion, right? How the movement is measured. So firstly, we will need to measure distances, right? So we'll understand how can we measure distances. What are the different measurement units, right? Then we will understand that why it is not possible to measure any length to its proper length, okay? Why there some error exists, okay? And then we will understand about the type of motion, right? What is a motion and how can it be measured? So let's begin. So students, in our daily life, we also need to measure distances of varying places. For example, when people go from one place to another, how do they know how far they have travelled? What is the distance between Delhi and Mumbai? What is the length of the track meant for jogging or racing? How far is your school from the home? How far is the destination point from the starting position for athletes, right? In all these examples, students, can you see there is a distance between, we are talking about two different places, right? We are talking from two different places. First place is about where we are, right? From where we are starting our journey. And then we are talking about a second place where we are ending our journey, right? For example, if we talk about the distance between Delhi and Mumbai. So Delhi is a place from where a person will start a journey. The Mumbai is the second place where it will end the journey. Similarly, if we are talking about how far is the destination point from the starting position for athlete. So athlete also starts running from a particular point and ends running at a particular point, right? So we are talking about two different places, okay, two different points. Now what is distance? So distance is basically the length between these 2 points, right? These 2 points. But how do we measure the distance between these 2 points, right? If the points are very close, okay, so we can measure it using what? The scale, right? But if the distance is so far, let's say for example, the distance between Delhi and Mumbai, how will I measure it, okay? So let's understand this in this chapter. So many other questions like the above in which we need to measure the length arise, right? So let's understand that. What is measurement basically? So measurement is the process of determining the size, length, amount or degree of something by comparing it to the standard unit. Student, it is a process of determining the length, the size, amount or degree of something, right, by comparing it to the standard unit. In this case also, right, for example, this is the place Delhi and this is the place Mumbai, right? So in this case we are trying to measure the length, right, the distance between them, okay. Sometimes we want to measure the size of something, right? Sometimes we want to measure the degree of something, right? So these are all what? Measurement. So this measurement provides a way to quantify and describe physical properties and dimension. Whenever I ask, let's say you go to a shop and ask for something, right? For example, sugar, right? You ask for sugar. So you will say, I want this amount of sugar, okay? So you are quantifying something, you are telling the quantity of something, right? That's the measurement, okay? So units of measurement are the standardized quantities used to express measurement. To express measurement, how much, right? Basically to quantify things, there are standard quantities. They provide a common basis for comparison and communication. Earlier times people used to measure things with the help of their body parts or with any other objects known as ancient methods of measurement. Later standard units were devised and accepted all over the world. Now earlier what happened, this measurement was also done earlier also, right? People used to measure distances, people used to measure the amount of grain they have produced, right, in that particular season and lots of things. So but earlier they used their hands right, some let's say some stone. These were the objects earlier which were used to measure things, right, but they were not standard, right. Later what happened, standardized units were devised and that were then accepted across the world. Now ancient methods of measurement included using body parts like handspan, right. For example, this is a handspan from here to here, right. So I can measure my arm from my handspan. For example, this is one handspan, then this is second handspan, right. So this is one handspan. Now cubit and arm span for various lengths. This is from here to here, this is called the arm span, and we used handspan, cubit, arm span for various lengths and the pace for distances, right. Now these methods provided practical ways to measure without standardized tools, right. So we used handspan, we used cubit, arm span, pace and footstep, right. These were not standardized tools, but they these methods provided a practical way to actually measure something, right. They were based on the dimensions of human body and everyday experiences, okay. So they were, although not standard, but they found to be very useful. Now what is a handspan? So the distance between the tip of the thumb and the tip of the little finger when the hand is stretched out. So this is not the handspan, this is the handspan when the hand is stretched out. It was used for measuring smaller lengths. So for example, we want to measure some small lengths, okay, then handspan was used. Cubit, so the length from the elbow, right, the length from the elbow to the tip of the middle finger, this, it was a standard measurement in ancient civilization like Egypt and Mesopotamia, used for building and craft purposes, right. So when people wanted to build something or craft something, right, then artisans used to use their elbows for the length, okay. So this was known as cubit. Now comes the arm span. So the distance from fingertip to the fingertip when the arms are stretched out. For let's say this person has completely open his arms, right. So from one fingertip to the fingertip of the other arm, right, that's called the one arm span. So this one arm span, it was used to measure larger lengths, right. Now the arm span has increased, right, the length has increased. Now this was used to measure larger lengths, and it was believed to be roughly equivalent to a person's height, okay. So the whole length from your one fingertip to the other fingertip of the other arm, that's the height of that person, okay. Now the other method was pace. So the length of a person's stride, measurement from one footfall to the next, okay, when we walk normally, right, that's called the pace. So it was commonly used for measuring distances, especially in walking or traveling, all right. Now let's go to the next page. Now we also had foot span. The width of person's foot, often used for measuring shorter lengths or for estimating dimensions in everyday task, okay. So the foot of the span was also used. Now what do you think, why these measurement methods were not still used in everyday activities or in making buildings, right, or making, let's say, some furniture, right. Earlier people used these measurement methods, for example foot span or pace or these things, right. So think why there would be a need to devise a new method completely, right, to measure something. Let's understand that. So before that, let's do one activity to know the length of a given table with your hand span, okay. So there's there's this table, okay, and you want to know the length of this table, the height, the length and the breadth, okay. So how would you measure it? Let's measure it using hand span. So measure the length of the table with your hand span, okay. So this is one hand span. Now measure its length, breadth and height. Say it is 5 handspan. Now ask your friend to measure the length of the same table by its handspan. It is not 5 handspan now, okay. So the number of handspan are different. So you can do this, for example, measure the length of a table with your hand. Now you can ask your father or your mother to measure the length of the table, of that same table with their handspan, okay. Now you will realize that the number of handspan are not same now. So the number of handspan are different. This shows that the length with respect to these units varies from person to person. It creates a lots of confusion. So use of these units is not trustworthy, okay. So this is the reason, right, when this handspan, the length of the handspan varies from person to person, right, and this was not trustworthy. So therefore people came up with a standard measurement method, okay. So this activity shows that we need some units which are fixed units of measurement, right. Yard and foot are some other ancient units of measuring length. So then people thought of making some fixed units of measurement, right, which can be used across the world, right, and shows the same measurement. Now comes the standard units of measurement. So these units of measurement are called standard units of measurement. The units which have fixed quantity and do not vary from person to person are called standard units of measurement. So anyone who measures using standard unit of measurement gets the same quantity, gets the same length, gets the same volume, okay. The standard unit is agreed upon by all people of the world as a basic unit of measurement, right. So this is accepted across the world. Everyone accepts this. Scientists all over the world have accepted the following standard unit for measurement. So for measuring length, the standard unit is meter, right, the meter. Standard unit of mass is kilogram and standard unit of time is second, okay. So the units of length can be interconverted by multiplying or dividing their values by 10, 1000, 100, 1000 and so on. This set of units is called International System of Units. So basically the length can be interconverted by multiplying, okay, multiplying it or dividing it. Now this system was adopted in 1960 and the units therein are commonly known as SI units, right. This is called the SI units. So 1 meter is equal to 100 centimeter. So centimeter, meter, right, kilometer, millimeter, these are all measurement unit for length, right, but the standard unit of measurement is meter, okay. So firstly, so the smallest unit of measurement is millimeter, right, then comes the centimeter, then comes the meter, okay, then comes the meter and next the kilometer, okay. So as we go from millimeter to centimeter to meter to kilometer, we keep on multiplying it, right, we keep on multiplying it, but as we convert the number from kilometer to meter, we divide, then meter to centimeter, we divide it, okay. So this is how we convert. Let's do it. So the metric system created by the French in 1719 makes for standard units, okay. So this metric system created in 1790 makes the standard units. Symbols for quantities are written in small letters like length in m, mass in kg and time in seconds, okay. So can you see these length is written with m, which means meter, and it is written with small m, right. Similarly small kg, similarly small s, which means second. Now symbols of units named after scientists are written in capital. For example, symbol of Kelvin is K, symbol of degree Celsius is C, okay. So symbols of the units that were named after the scientist, okay. So Kelvin was a scientist, Celsius was some scientist, right. So therefore the C and the K is capitalized. Now the symbols for units are not allowed by a full stop, okay. So after that symbols for units are not followed by a full stop. after for example writing m, here I have written m, right. So it will not be followed by a full stop. Okay. Symbols for units are not written in plural. I cannot write masses. For example, I want to write mass, right. This is singular. Let us say I want to write masses. So I cannot write like this. Okay. This is wrong. Okay. I cannot write kgs like this. Okay. So these units are only exist in singular and not plural. Okay. Now, can you recognize this scientist? He is Leonardo da Vinci. Was a famous artist and inventor. He improved balance scales and made precise drawings. His work helped advance measurement techniques. Okay. So Leonardo da Vinci was a famous artist and inventor also. He improved balance scales and he used to make beautiful paintings which used to have precise measurement. So his work of paintings helped people to understand measurement technique in much more better way. Now let us understand the correct measurement techniques. So the distance of something from one end to the another end, it's called length, right. We talked about in the beginning of this chapter, right. For example, Delhi to Mumbai, right. We are talking about the length between these 2 points. So the standard unit of length is meter, right. So the distance can be measured in meter. All right. Now 1 meter is a length between the 2 points marked on a rod made of an alloy of platinum and iridium at 0 degree Celsius. This rod has been kept at the Bureau of Weights and Measures at Paris. In India, a copy of such meter has been kept in National Physical Laboratory, New Delhi. So to standardize these measurement techniques, what people have done, they have actually put 1 meter length, right, in for example one in Paris, right, and we have also in India in National Physical Laboratory, right. So 1 meter is a length between 2 points marked on a rod made of an alloy, right. It is made of an alloy of platinum and iridium at 0 degree Celsius, right. Now we have a rod which tells us that okay, this is 1 meter. Now the length of a room, the height of a building, the length of the breadth of a playground are measured in meters. So these are all measured in meters, right. Now let us go to the next page. The instrument commonly used for measuring length are geometry box scale, half meter scale and measuring tape. So to measure length, what we use? We use geometry box, right. Geometry box has 1 to 12 centimeter scale, right. Then we use meter scale, we use measuring tape, right, table measuring scale, right. This measuring tape is used by tailors, by architects also, right. So the choice of measuring instrument depends on the size and the kind of object to be measured. For example, for measuring small lengths, right, for measuring small length you can use this scale, geometry scale, right. We have to use an instrument marked in centimeter and millimeter. At the same time, we also take care that the marking has the has centimeters and millimeters in it, right. So based on the object that we want to measure, based on the length of that object, we choose that particular kind of measurement tool. Do you know, students, National Physics Laboratory in India maintains 6 base units, namely meters for length, kilograms for mass, seconds for time, Kelvin for temperature, ampere for current and candela for luminous intensity. So at National Physics Laboratory in New Delhi, they have maintained these 6 basic units. Okay. So here you will know that okay, this length is called meter, this amount of weight is called 1 kilogram, this amount of time is called 1 second. Okay. Similarly for temperature and luminous intensity and current. All right. Now let us understand submultiples and multiples of SI in SI units. So name of unit is called deci. deci, centi, milli, micro, kilo and mega, right. So, deci means 1/10, right, 1/10 of something. Let us say this I have a piece of, I have a bar, okay, this is a wooden bar. Let us say I cut it in 10 pieces. So, I cut it in 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, okay. So, this one piece would be called 1/10th piece, okay, 1/10th piece. So, this is called deci, right. So, 1/10, right. Similarly, we have centi, similarly we have milli, micro, kilo and mega, right. Now, kilo, mega is the largest unit, you can say, okay. It is 10 raised to the power 6 and kilo is 10 raised to the power 3, okay. Now, let us understand the standard units of meters and its multiples. So, we have standard unit meter, okay, but as the length increases or decreases, we have smaller units also. For example, we have decimeter, okay, decimeter, we have centimeter. 1 meter is equal to 10 decimeter, right, and decimeter can be written as 10 raised to the power -1, okay. Similarly, 1 centimeter is equal to 100 centimeter, which means 10 raised to the power -2, okay. So, similarly, 1 decimeter can be converted to 10 into centimeters, 1 centimeter can be converted to millimeter, right. Now, we have multiple units also, the larger units also, like decameter, okay, then hectometer, okay, kilometer. So, let us do one sample problem to understand these. So, the height of a person is 1.65 meter, express it in centimeter and millimeter, right. So, we have 1.65 meter and we have to convert it into what? Centimeter and millimeter. We know that 1 millimeter is equal to 100 centimeter, okay. Now, we want to convert it into this centimeter. Now, 1.65 meter means what? Multiplying 1.65 into 100, alright, which comes out to be 165, alright. Similarly, 1 meter is equal to what? 1000 millimeter, okay. Now, 165 meter, for 165 meter is equal to 1.65 meter into 1000, right. This comes out to be 1650 millimeter, right. So, this is how the conversion takes place. Similarly, for distance, the distance between Radha's home and her school is 3250 meter. Express this distance in kilometer. Now, we know that kilometer is, we know that 1000 meter is equal to 1 kilometer, right. When we will keep 1000 meter length, when we will keep meter length 1000 times, we will get 1 kilometer, okay. So, which means that 1 meter is equal to 1/1000 kilometer, right. We will take this 1000 to the next side, right. Now, we want to convert 3250 meter. So, 3250 meter is equal to 1/1000 into 3250, right, which comes out to be 3.25 kilometer, right. Similarly, you can understand this for measuring length, okay. Now, let us go to the next page. Now, we will understand how do we measure different lengths with using different scales, right. Let us begin with meter scale. So, measurement of length of a postcard with a meter scale. Place the scale parallel and very close to the length of the given postcard. Carefully slide the scale slowly for its full mark, says 0 centimeter, with the first end of the postcard. Now, note to coincide the mark on the scale coinciding with the last end of the postcard. let it be 7.90 centimeter. The length of the postcard will be 7.90 centimeter. So how you can measure this? So basically you have this postcard, right? Place your scale, the meter scale, okay, with one end from here, right? And this and the scale should start with 0, okay. So basically you are starting with 0, okay, and then you have to note the length where postcard is ending, right? So for example, it could be 7 or it can also be in point, right? So for example, this is a centimeter scale, okay, 0, 1, 2, and this is how it goes on, okay. So between 0 and 1 there are 10 small marks, okay. So 1, 2, 3, 4 and then 5, 1, 2, 3, 4 and this 1 fifth, okay. So this also looks like this. For example, the postcard ends somewhere here, right, somewhere here. So how will you say, how will you measure the length? We will see, okay. So you will say 5, 6, 7, okay. So basically 0.7 or whatever the length may be, for example 7.7, right. This is how you will measure length using the meter scale. Now while using a ruler for measuring length, we have to take following precautions. What? First, keep the scale parallel and very close to the length of the object to be measured. So whatever object you want to measure, right, first of all keep the scale parallel to it, right, keep the scale parallel to it, okay. Let's say you want to measure this length, right, place the scale like this. If you want to measure the breadth, put the scale like this, okay, parallel to it, also very close to it. Now generally the ends of the scale are broken, so let any full mark of the scale coincide with the first end of the object and subtract it from the reading of the scale at the other end of the object. So sometimes what happens is the end of the scales are broken, right. In that case you can just make sure that the centimeter, that you start with the number with the scale which has proper marking, right, and then count accordingly. Now I should be exactly above the point where the measurement is to be taken, okay. So make sure wherever you are taking the measurement, right, it is exactly above the point, right. Now measurement, measure the height of a person with measuring tape, right. Now we will understand how measuring tapes are used. So to measure the height of a person, make him her stand absolutely straight with his or hand back against a wall, okay. So this is how you want to, this is how you have to make a person stand, okay, against the wall, okay. Now make a mark on the wall where his or her head touches the wall, okay. So make a mark like this on the wall. Now measure the length from his mark to the floor with the help of measuring tape. So now you can, from this mark, measure, use the tape and measure it to the base of the floor, okay. Now this is how you will measure the length of a person. So what are the precautions one should take while measuring the length using the measuring tape? Firstly, to take the accurate measurement, we can place a thick rigid book or the head of a person whose height we are measuring, okay. So what we can do, rather than just marking the point on the wall, we can use the rigid book or something very straight like cardboard, so that this gives the exact point, okay. The person should not wear shoes to gain some extra height, right. So make sure the person is not wearing anything, right, like chappals or foot or any kind of shoes. The eye should be exactly above the marked point where the measurement is taken. This gives the height of the person. So you have to this is how you have to measure it, right. This gives the height of the person. Now what are the errors in measuring length? So, while we measure length, right, some errors can be found in measuring instrument. These errors may arise like due to thickness of the scale, right. When the scale is thick, the error can arise, okay. Due to wrong placement of the scale, the measuring tape or the meter scale can itself be wrong, right. There is a possibility that the scale is itself wrong. To get accurate result, we should remove these errors, and for this we should take the following steps. So, while taking the reading, our eye should be in an accurate position or above the point, right. So, we should keep our eyes in an accurate position, okay, or above the point, right. For example, I marked a point here, right. So, my eye should look here, okay, just above the point. In case of measuring instrument being broken at the edge point, start your measurement from any other clear mark, okay. So, there might be a possibility that the measuring instrument is broken at both the ends, right. So, start measuring with the measurement where it is clearly marked, okay, and then count accordingly. Now, let us understand how can we measure curved lines, right. These were all the straight things. Now, how can we measure curved lines? So, measuring curved lines can be difficult with straight rulers, right. Instead, we use flexible tools like measuring tapes or strings. To measure a curve, we place the tape or string along the curve without stretching it. Then we straighten the tape or string and measure it with a ruler. This way, we get an accurate length of the curve. This method is useful for many tasks like sewing clothes or drawing maps. So, see, when we measure a curved line, we cannot use the scale, right, because it is fixed, okay. So, we use the flexible tools like measuring tapes or strings which cannot be stretched, right, and then we put the string or the measuring tape along the curve without stretching it, and then we finally measure it with a ruler, all right. Now, let us follow the given step to measure a curved line. Now, let us go to the next page. So, to take a divider to measure a line AB as shown in figure. So, this is a curved line, right. Now, open the legs of a divider and measure the small position of the curved line, okay. So, what you can do is measure these small positions, okay, measure these small positions. Now, keep on changing the position of legs of the divider alternatively and count the number of times the divider has to move from point A to B, okay. So, let us say it took how many times? 1, 2, 3, 4, 5 and 6 times, right, to reach from A to B, okay. So, basically you moved your divider 6 times. Now, measure the distance between the two legs of the divider and multiply it with the number of times it has moved along the curved line, okay. So, count the number of times the divider has changed its position, right. For example, from A to B it has changed 1, 2, 3, 4, 5, 6, okay. So, we can measure the distance measure this distance, okay, and then we can multiply it with 6, okay. This gives us the length of the curved line, okay. Now, you can check your progress by filling these blanks, okay. Now, let us understand how we describe a position, right. So, describing position tell us where the things are, right. So, it helps us find place and move around. For example, if a book is on the table, we know where to look. For example, I asked you, where is the book? You said it is on the table, it is in the bag, right. So, now by describing its position, I know about it something, right. So, without describing position, it would be hard to find things. So, saying the pencil is on the desk, right. So, it makes clear that the pencil is kept on the desk, right. Now, I know that I can find pencil easier as it is on the desk, right. So, when we describe a position, when we tell a position, it helps us to understand about that particular thing. Okay, it gives some detail about it. For example, so a reference point is crucial because it helps us describe the position clearly, right? So reference point is a point or in context with an object which describes the position clearly. It acts as a starting place to compare other location. For example, saying the book is to the right of lamp on the desk, right? So uses the lamp as a reference point. So when I am saying that the book is on the right of the lamp, right, on the desk, so here I have used lamp as a reference point, right, to describe the place of the book. Okay, so this makes it easier to understand where the book is. Without a reference point, it would be confusing to describe where things are. Thus, a reference point is a fixed place used to compare distances, right? So a reference point is a fixed place which is used to compare distances. Let's say, in other words, when distance is started with respect to a fixed object or point, then this point is called a reference point. Okay. So for example, when you walk a highway, right? Let's say you have started traveling on a highway, right, which can be named as XYZ, right, and you are moving towards Delhi, right? Okay. So let's say you are moving from Goa to Delhi, right, and this is the highway for Goa to Delhi, right? So this place would be a reference point for you. This point would be a starting point for you. Okay. Now, thus a reference point is a fixed point, right? This is a fixed point. Now, let's see this through one example. Imagine you and your friend wants to find out if the park or the new ice cream shop is closer. Okay. So if you each measure from your own homes, you might get different answer, right, because you live at different place, your friend lives at different place, right? So you both will get different answers, right, about the distance. So in this case, what you will do, you will take a reference point. Okay. So if you measure, both of you will get different answers, but if you all measure from the school, which is the same for everyone, you will get the same answer, right? And this common point is your reference point. Okay. So let's say if you want to measure the distance of the house, okay, and the ice cream parlor, okay. So from the house of Ram and Sham, right, then in this case the distance would be different, right? But let's say if we say that we want to calculate the distance of ice cream parlor and the house from the school, then by stating this position, by keeping school as a reference point, we have fixed the position. Now in this case the answer would be same in both the points. Now let's take another example. So Anil was on a bus going to his grandparents' house in Bangalore. He was excited to get there and looked at the kilometer stones on the road. One stone said Bangalore 80 km, the next said Bangalore 70 km. These stones showed how far he was from Bangalore, which was his reference point. As the numbers got smaller, he knew he was getting closer to his destination. Now let's say we all have travelled on roads and we also have seen these stones, right, representing and telling us the distance left towards our destination, right. So these are all the reference point as with respect to our destination. So for example, I am saying Bangalore 60 kilometers. So this means that from this point, right, the Bangalore is 60 kilometers away. The reference point 40 kilometers Bangalore indicates that from this point Bangalore is now 40 kilometers away. Okay. So basically the reference point tells more about describes the position, right. Now what is the importance of the reference point? So importance of the reference point play following important role in describing the position of an object, right. Basically reference point is what? It is basically a position of the object, right. So a reference point provides clarity in describing location, right. It gives clarity about the location, okay. From these stones, they are basically clearly telling us the distance. It is saying 20 kilometers, 0 kilometers, 40, 60, right. So they are basically giving clarity about the location. Now it also offers a starting place to compare other positions, okay. So it also provides a starting place to compare it with different positions. It makes communication easier and more precise, right. Using reference point, the communication can be standardized, right. We can also tell other people about the distance that is left, okay. This is a standard way. Now let's go to the next page. And it helps in navigation and finding objects. So when we are navigating, right, using these stones, using these reference points, we get to navigate better. We find our destination, the objects in a much more easier way. It avoids confusion about location, right. When we have placed a reference point, right, we have located one particular thing, there is the confusion about the location is removed, is avoided through this, okay. Now let's understand about the motion. What is motion? So in our daily life, we see many things which move from one place to another, right. We see a man walking, a dog running, a fish swimming, and a snake creeping from one place to another, right. We have seen so many things moving, running, right, changing their places. So some non-living things also show motion. A bus or train moves from one place to another. Minute and hour hand of a clock also move through, though they do not seem to be moving, right. So we see a variety of objects moving. We see a car moving, right. The hands of the clock are also moving, okay. So on the other hand, there are some objects which do not move. For example, your house, the school, the trees, they do not move, right. They are fixed at a particular place and they are called stationary or at rest, right. Now what is motion? So we discussed about that. Some when we look at things, we find some things are moving, some things do not move. They remain fixed at their place. So what is motion? An object is said to be in motion if its position changes with respect to the reference point with time, okay. So motion, what is motion? Motion is basically the change in position, okay. It is a change in position with respect to the reference point with time, okay. So we are saying that the position from, let's say, A to B then to C is changing, right, with respect to what? With respect to the time. So we are taking reference point, okay, of what? Time. Let's say when I started my journey, it was 3 o'clock in the morning, right. When I reached B, it was 3:45 AM. When I reached C, it was 4:30, right, AM. So can you see the time has also increased, the time has also moved, and similarly, and with that the motion, the distance was also covered, right. So this is motion. Thus the change in position of a body with respect to a reference point is called motion. So we can say that motion is change in position, right, the change in position with time, alright. Now let's do one activity to know the object that are in motion. How do we know that objects are in motion? So make a list of objects in your surrounding according to their motion. So write the name of the object, write the right whether they are in rest, motion, living or non-living. So, for example, let's say house. House is at rest, yes, not in motion. Living or non-living, so it is non-living. Okay. So, similarly, you have to fill this table. By this, you will observe, you will notice that some objects are at rest and some are in motion, and there are many objects in our surrounding that are in motion, right. Now, let us go to the next page. So, there are different types of motion. Now, we understood what is motion, right? It is a change in position with time. Now, motions are mainly of the following types: linear motion, rotational motion or circular motion, oscillatory or vibratory motion, periodic and non-periodic motion. So, first of all, let us understand them one by one. First is linear motion. So, motion of a body along a line is called a linear motion, right. So, when an object moves in a straight line, okay, it is called a linear motion. The motion of a car or train, bullet fired from a gun, a boy sliding down a slope, a ball rolling on the ground and the drawer of a table are all examples of linear motion. Okay. So, linear motions are basically what? The change in position in a straight line. Okay. Now, linear motions is itself of two types: rectilinear motion and curvilinear motion. Now, rectilinear motion means the motion of an object along a straight line, it called rectilinear motion. Okay. So, when the motion is in the straight line, okay, that is called the rectilinear motion. Example of rectilinear motion is motion of a bullet fired from a gun, motion of a car along a road, falling of a stone, motion of a ball after a powerful shot by a batsman, motion of a boat march past by soldiers and motion of an ant in a straight line. So, these are all examples of rectilinear motion. So, when a bullet is fired from a gun, it always travels in a straight line. Okay. When a car moves on a straight line, it follows a straight path, right. So, in all these examples, the movement in the straight line. Now, next comes the curvilinear motion. So, motion of a body along a curved line is called a curvilinear motion. So, when the motion is along a curved line, right, it can be a slightly curved, right, or more curved. So, for example, a car moving in a bend or a man walking along a curved path, right. For example, this is a park, right, and the person is moving like this. Okay. So, for him, he is moving in a straight path, okay, but if we take a broader picture, he is actually moving on a curved path, right. So, this is an example of curvilinear motion. Now, let us come to the second motion, which is rotational motion or a circular motion. So, motion of a body along a circular path is called rotational or circular motion. Motion of hands of a watch, motion of a running fan, motion of wheel of a charkha, motion of a spinning top, motion of a merry-go-round, a bull moving around a central pole, motion of the moon around the earth and the motion of the earth around the sun are all examples of rotational or circular motion, right. So, in this case, right, what is happening? This is a rotational or a circular motion. A particular thing, let us say a particular thing is moving in a circular motion, right, and in this it has a center, right, it has a center and it is moving in this circular motion. For example, let us talk about the hands of a watch, right, the hands of a watch are moving and it has a center, right. Now, the motion of a spinning top, right, the spinning top also has a center and it spins like this. If we talk about the motion of the moon around the sun, right, let us say the moon is moving around the sun, right, this path is circular, but it has some center, right. So, why I am telling you this? Because you can because we just talked about the curvilinear motion, and curvilinear motion also talks about movement of the object in a curved path. So, this is also a curved path, right. But what is the difference between curvilinear and rotational motion? Is that rotational motion moves in a circular motion and it has a center point, whereas in curvilinear motion there is no center point. For example, a person can walk in a park which has like this path, right? So this path is also a curved path, right? This is a curved path, this is a curved path, but it has no particular center, right? Now can you understand and differentiate between curvilinear and circular motion? Sometimes both linear and circular motion occurs simultaneously. How? So let's say this is a circular motion, right? But if we look closely, let's say I take only this part of this, let's say take only this part of this full motion, right? So I will say this is what? A linear motion, right? So a very small portion of a circular motion looks like a linear motion. For example, wheels of a vehicle such as car, bus, cycle or train show circular motion, right? They show circular motion around the axis but also perform linear motion on the road. So the motion they are performing, let's say this is the wheel, okay, and this is the road. So the motion it is performing on the road, it is what? The linear motion, but actually it is moving across a point which will be called rotational or the circular motion, right? Now let's do one activity to understand and observe and the circular motion using an eraser and a thread. So what you have to do is tie an eraser or a potato to one end of the thread, okay, and hold the other end of the thread and spin it around in a circle. So what you have to do is take a thread, tie its one end with the eraser, right? It's easy, it will be easy for you. Now since on one end of the thread there is some weight, right? So when you will spin the thread, it will move in a circular motion, right? It will move like this. Now spin it around in a circle. Watch the motion of the eraser as it moves, right? You will observe that the eraser moves along a circular path, okay, similar to the motion of a merry-go-round. This shows that the circular motion of the eraser demonstrates circular motion, where an object travels around a central point in a curved trajectory, right? So here what you understood, that a circular motion has a center point, right? Has a center point, okay, around which it moves, okay. Now let's go to the next page. Next, another type of motion is the oscillatory or vibratory motion. So to and fro motion of a body about its mean position along the same path is called an oscillatory motion. So have you ever seen somebody swinging on the swing, or have you yourself have tried swing, okay? So this kind of swing shows oscillatory motion, right? It is oscillating. Similarly, we see in pendulum, right? The pendulum, this thing, right? The pendulum moves. So this is the central position and it goes like, it goes here, then it comes back here and then it goes here, okay. So the pendulum moves like this, okay, and this is called the oscillatory motion, okay. Now another is the vibratory motion. Vibratory motion is another kind of oscillatory motion in which the body does not move as a whole. In this motion, the moving object undergoes change in shape or size. So what happens is, vibratory motion is another type of oscillatory motion in which the object doesn't oscillate. In this case, the pendulum was oscillating, right, was changing its position. But in vibratory motion, the object doesn't change its position, rather the moving object itself undergoes change in shape or size. So let's understand this with an example. In case of vibratory motion, a metallic wire which is stretched between 2 points A and B, when released, begins to vibrate. It shows vibratory motion, So let's say in guitar, okay, or let's say you just take a thread, right, and stretch it, basically one end of the thread, place it at point A and press it, and the other end of the thread, place it at B, okay, and make sure there is a tension at both the ends, right. Now when you will touch it, it will just move, it will just vibrate, right. So basically the position of the thread will change, right, it will go up and down so fast that we will not be able to see it, right. Similarly, this vibratory motion happens in case of musical instruments such as violin, sitar, guitar and drums produce vibratory motion, right. The drums, the flat part of the drums when hit by a stick, right, it shows vibratory motion, right. Similarly, in case of guitar, the strings of the guitar shows the vibratory motions, right. The strings moves up and down so fastly, so in such a speed that we cannot even see, but we can feel the vibration, right. So vibratory motion produces sound. Now during breathing also, our chest expands or contracts, and this motion is also a kind of vibratory motion, right, and that is the reason we can speak, right. Now let us do one activity to explore and identify oscillatory motion using a metal strip, okay. So use a metal strip approximately 40 centimeter long, fix one end of the strip to a table by securing it with a book or a brick, lightly press and then let go of the free end of the strip. Now watch how the free end moves up and down continuously. So take a metal strip, or you can also take a scale, the bigger one, right, the metal scale, and place it on the table. Make sure you keep static the one end of the metal strip using books, okay, and make sure the other end of the metal strip is free, okay. Now lightly press the other free end and let it go. So you will see that it is moving up and down, right. So the free end of the strip exhibit an up and down motion repeatedly after being pressed and released. So this tells that the consistent up and down movement of the strip demonstrate oscillatory motion, illustrating how objects can vibrate back and forth in a regular repetitive pattern, okay. So this motion, right, of the scale of up and down is called the oscillatory motion, right. Now when the same thing happens with the speed, right, with the speed, in this case we can see that it is moving up and down, but when it happens with the speed, it creates vibration, right, and also sound, alright. Now let us understand the fourth type of motion, which is periodic and non-periodic motion. Note the time by the minute hand of a clock to complete one round. Repeat this process thrice. You will find that the time taken by the minute hand of a clock to complete one rotation is always the same, right. Let's say if we talk about the clock, right, the clock starts with let's say there are 12 numbers, right. Let's say the clock starts with the 12th number, right. The minute hand, basically it takes the same amount of time, right, when it reaches back to 12. Repeat this exercise for 3 times, right. You will see that it is taking exactly 1 minute in both the 3 cases, right. This is called the periodic motion, right, the period, the motion which is repeated after equal intervals of time, right. This motion is repeated, right. Can you see the motion is repeated? The movement is repeated after an equal interval of time. This is called a periodic motion. This is seen in case of earth, the movement of the earth around the sun, right. It takes exactly the same time, right, every year, okay. Now examples are motion of a swing, motion of the pendulum of a clock, right, motion of the moon around the earth, and motion of the earth around the sun are all examples of periodic motion, right? They have fixed interval. Now let's go to the next page. Now periodic motion can be used to measure time also. Clocks and battery operated quartz watches are some time measuring devices which utilizes periodic motion. So periodic motion, the movement, basically it is the circular movement, you can say, right, which shows that one portion has completed, one circle has completed, right. So basically periodic motion is used to measure time, and this exactly the same thing happens in case of clocks. Okay, motion which is repetitive but not after a set of period of time is called non-periodic motion. So for example, a motion is periodic. For example, a motion is repetitive. It is happening again and again and again, but not on a periodic motion. Let's say when this is a stone and it is attached with a thread, right. Now you just push it in one direction. What will happen? It will go like this, like this, like this, and slowly after some time it will stop at this same position, right. This tells that the motion was repetitive, right. It was moving like this again and again, but it was not periodic. It was not taking the same time to come back to the center, right. For example, swinging of our arms and legs, beating of the heart, motion of the chest during breathing, and a kite flying in the sky are all examples of non-periodic motions, right. In this chapter we have learned few new words, so let's recall them. Measurement, quantity of some particular property of an object. Okay. Standard unit, a unit agreed upon by a large group of people as a basic unit of measurement. Least count, smallest quantity which can be measured by a given measuring instrument. Motion, continuous change in the position of a body with respect to a stationary object. Linear motion, motion of a body along a line. Circular motion, motion of a body along a circular path. Periodic motion, motion which is repeated after equal intervals of time. Okay. Now let's get to the main points of this chapter. To know about the quantity of some property of an object is called its measurement. To know quantity of an object with which we compare other similar things is called a unit of measurement. Observation, footstep, cubit and handspan are some of the common units of measuring length. But these common units are not trustworthy. Our senses cannot make correct measurements. The unit which is agreed upon by most of the people in the world as the basic unit of measurement is called standard unit. Standard units are essential for the sake of uniformity. Standard unit of length is meter, standard unit of mass is kilogram, while the standard unit of time is second. We measure the length while measuring height, depth, area, thickness or diameter of an object. Instruments commonly used for measuring length are a ruler, a half meter scale, a meter scale and a measuring tape. Choice of measuring instrument depends on the object to be measured. Measure of the surface of the object is called an area. Area of an irregular surface can be calculated with the help of graph paper. Now let's go to the next page. A reference point is crucial because it helps us describe the position clearly. It acts as a starting place to compare other locations. Continuous change in the position of a body with respect to stationary object is called motion. Various kinds of motion are linear motion, rotational motion, random motion, oscillatory vibratory motion, periodic and non-periodic motion. Motion of a body along a line is called linear motion, and linear motion can be rectilinear or curvilinear motion. Motion of a body along a straight line can be uniform or non-uniform. So I hope students this chapter is now clear to you. So based on the learning from this chapter, you have to revise and do the exercise in your homework.